Hello everyone. In this section we are going to discuss four main topics: the tangents, the velocities, the derivatives, and the rates of change. Let's start with the first topic, which is about the tangents. So what is basically the tangent for any curve? For example, if you have any curve, this curve, what is the meaning of a tangent line at any point for that curve? So at this point, the tangent line means the line that touches this curve in only one point, in only that point. So for example, the tangent line at this point will be this line. Why? Because it touches only the curve at this point only. And for that point, for example, the tangent line will be this line, one. Okay, so what is the meaning of the tangent line? Is the line that touches the curve that I have only at the point given. The first idea of the tangent line, I will have a curve, okay, and from that curve, I need to find the equation of any tangent line at any point. So we're gonna solve two examples about how to find the equation of that tangent line. Okay, since it's a line, we know that for any line in general, the equation of it can be written as y minus y1 is equal to what? Equal to the slope times x minus x1, where x1 and y1 are two real numbers which they represent the point. Okay, so for example, if I want to find the tangent line of that curve at this point, okay, this will be my tangent line, and for this tangent line I need to find what is the equation of that line. So the general form for that equation will be this. What is x1 and y1? x1 and y1 will be, this will be y1 and this will be your x1. So we know that any point in the curve can be represented as x1, x coordinate, and y coordinate. So the x coordinate is equal to x1 and the y coordinate will be your y1. Okay, so for this equation to be written, I need to find what is y1, what is x1, and what is the slope. x1 and y1 already known. He will tell you in the question, find the tangent line or the equation of that tangent line at this point. So the point will be given, which is the x coordinate and y coordinate. Okay, for that m, or for the slope of the tangent line, we can find it by either applying this formula or this formula. So now we are going to solve two examples. The first example will be using this formula, and the second example will be using the second formula. Okay, so for the first example, if we read it, he needs from us to find the equation of the tangent line, So directly, if I need to find the equation of any line, I will write y minus y1 is equal to mx minus x1. And for that equation to be well written, we need to find what is y1, what is m, and what is x1. So we have the curve and we have the point. Find the tangent line for that curve at this point. So what will be my curve? This is the curve, which is the parabola. Okay, and I need to find the tangent line at 1, 1, this point, P. So the tangent line will be this line, and I need to find the equation of that line. What will be? So from here, from the point, we know the point, any point can be represented as x coordinate and y coordinate. So this is equal to 1, 1. By comparing, x1 will be 1 and y1 will be 1. So already I found the y which is equal to 1 and the x1 is equal to 1. I still have to find what is the m. So for the m, I told you that you can use either of the previous formulas that I gave you. For this example, I'm gonna use this formula. Okay, so m is equal to what? It's equal to the limit when x approaches a for f of x minus f of a x minus a. So what is the a here? The a is basically your x. What is the x here is equal to a. So the m will be limit when x goes to 1 instead of a. Instead of every a, I'll just write 1. F of x minus f of 1 over x minus 1. And this will be equal, f of a means what? Means, here's my function, f of x will be equal to x squared. And f of a, I'm going to substitute with every x by 1. So it will be 1 squared, which is equal to 1. So f of 1 will be 1. And f of x will be what? Will be x squared. So this will be equal to limit when x goes to 1 for the f of x, which is x squared, minus 1 over x minus 1. Finally, I need just to find the limit of that expression. If I substitute directly, I'll get 0 over 0, which is undetermined form. Okay, so if you find 0 over 0, we know if I find 0 over 0 or infinity over infinity, negative infinity over infinity, I have to do something to get rid of that 0. So to get rid of that 0, I will factorize the numerator using the following formula. If I know that a squared minus b squared, if I have a number squared minus a number squared, this can be factorized as a minus b and a plus b. Okay, but x squared minus 1 one is equal to 1 squared, so this can be factorized as x minus 1 and x plus 1. So this will be equal to limit when x goes to 1 for x plus 1 x minus 1 over x minus 1. This will be cancelled out. Then I'll have x when x approaches 1 for x plus 1. Substitute directly since I have a polynomial. This is equal to 1. So this is equal to 2, and this 2 represents what? Represents the slope of that line, of the tangent line, at only this point. Because every point, if I choose another point, for sure I'll get another value. Okay, but for this specific point, I found that slope. So finally, I'll substitute with that equation. Y is equal to y minus y1 is equal to the slope x minus x1. I have found that y minus 1 is equal to the slope, which is 2, x minus 1. With some arrangement for the equation, I'll get y is equal to 2, x minus 1 plus 1. And then if I distribute the 2, we'll get y is equal to 2x minus 2 plus 1. Finally, y will be equal to 2x minus 1. And this is your equation of the tangent line at the point 1, 1. Okay? For that example 2, I'll use the other formula. Okay? And I have the same question, and I need to find what is the equation of the tangent line. I have the curve and I have the point. From the point directly, x1 is equal to 3 and y1 is equal to 1. For any line, the equation is equal to y minus y1 equal to m x minus x1. Okay, so I have found the x1, which is equal to 3. I have found the y1, which is equal to 1. And then for m, I'll apply this formula here. The formula says the limit when h approaches 0 for the function of a plus h minus f of a over h. So what is a again? A is just the x value. So this will be limit when h goes to 0 for the function 3 plus h minus f of 3 over h. What is my f of x? F of x is equal to this. So f of x is equal to 3 over x. And if I need to find f of 3, I'll just substitute x by 3. So 3 over 3 will be 1. Okay? For this one, already done. What is f of 3 plus h? So here, instead of every x, I'll just substitute this. Instead of every x, I'll just substitute with 3 plus h. So here, f of 3 plus h will be equal to 3 over 3 plus h. So let's find it. M is equal to what? Now f of 3 plus h, which is equal to, limit when h goes to 0, f of 3 plus h, which is equal to 3 over 3 plus h, and then minus f of 3, which is 1 over h. Okay, and of course if you substitute directly, you will get 0 over 0. Since you get 0 over 0, then you should make a change to get rid of the 0 in the denominator. Here, to write these two numbers or these two fractions as one fraction, I'm gonna comment I'm gonna make the denominator as common between them. Okay, so 1, we know that 1 can be written as any number over that number. So 3 plus h, and 1, I'm gonna write it as 3 plus h over 3 plus h over h. Okay, and this will be equal to limit when h goes to 0 for what? 3 minus this, minus the whole thing, over what? The denominator, the common denominator, which is 3 plus h, okay, over h. Okay, just distribute the negative 1 inside the bracket, and I'll get 3 minus h over 3 plus h over h. 3 will go with the negative 3, and I will have m is equal to limit when h goes to 0 for negative h over 3 plus h over h. Sorry, this is h. Okay, so here, this is the main fraction, and I have this over this. So we know that if I have a fraction a over b over c over d, this can be written as a times d over b times c. So here h can be written h over 2. Then this is equal to limit when h goes to 0 for negative h times 1, which is negative h, over h times 3 plus h. This h will go with this h. Then limit when h goes to 0 for negative 1 over 3 plus h. If you substitute directly, you'll get 1 over 3, negative 1 over 3. So finally, my equation will be what? Y minus y1, which is equal to 1, is equal to x, the slope negative 1 over 3, x minus x1, which is 3. And if you rearrange it, you will get y is equal to negative 1 over 3, x minus 3. If I put this in the right hand side, will be positive 1. And then this is equal to, just distribute the negative 1 over 3. Be careful with the negatives. Plus 1, negative 1 over 3 times negative 3 is equal to 1. And then plus 1. And this is equal to negative 1 over 3x plus 2. So y will equal to this.